I think in this century, we'll probably pick up signals from an extraterrestrial civilization.
To explore the universe beyond our solar system, NASA launched the Voyager 1 probe in 1977, not knowing it would become one of humanity's greatest achievements in space exploration. This small spacecraft marked a historic era in our collective imagination and continues to inspire generations. Voyager 1 has vastly expanded our knowledge of the solar system's outermost regions and still delivers groundbreaking insights into the cosmos. Its journey is a symbol of human curiosity and our desire to uncover the unknown. Recently, however, the spacecraft experienced an unusual encounter with an unidentified object in space, puzzling physicists around the world. What did Voyager 1 contact? And how much longer will it continue its mission? The spacecraft launched aboard a Titan III Centaur rocket from Cape Canaveral on September 5, 1977. Its initial mission was to study the moons of Jupiter and Saturn, with a special focus on Saturn's moon Titan, as well as the planet's magnetic fields and ring systems. Equipped with state-of-the-art instruments like cameras, spectrometers, and plasma detectors, the car-sized probe gathered invaluable data as it traveled. After a 2.5-year journey, it reached Jupiter, making its closest approach on March 5, 1979, and continued sending back images until April. Soon after, its sister probe, Voyager 2, followed a similar path. Among their most surprising discoveries was evidence of active sulfur volcanoes on Jupiter's moon Io, something never observed from Earth or by earlier missions like Pioneer 10 or 11. The four Galilean moons, Io, Europa, Ganymede, and Callisto, were revealed to be part of a complex lunar system. Voyager 1 also confirmed Jupiter's powerful magnetic fields and dangerous radiation belts. As it moved toward Saturn, the probe uncovered even more secrets. On November 12, 1980, it passed just 75,000 miles from Saturn, discovering the planet had far more moons and hundreds of rings, each composed of countless small particles. Most significantly, Voyager 1 identified an atmosphere on Titan, making it the only moon in the solar system known to possess one. In 2012, Voyager 1 made history again by becoming the first human-made object to enter interstellar space, over 13 billion miles from Earth, where it continues to transmit valuable data. Scientists once believed this transition would be smooth and uneventful, but instead, Voyager entered a strange and complex region of space. The solar wind, charged particles ejected from the Sun's atmosphere at speeds over 620,000 miles per hour, slowed down near the spacecraft and eventually became undetectable. At the same time, galactic cosmic rays, high-energy particles from supernova explosions, suddenly increased, as expected when leaving the Sun's influence. Yet oddly, instead of coming from all directions as predicted, these rays mostly came from one. Even stranger, the magnetic field around Voyager 1 remained unchanged, despite the dramatic drop in solar particles. This contradicts the expected behavior, given the galaxy's magnetic field is believed to be tilted by about 60 degrees compared to the Sun's. Adding to the mystery, Voyager 1 detected a faint plasma hum unique to interstellar space, which researchers compare to the sound of light rain. Since 2012, scientists have been using the spacecraft's instruments to study this new environment in unprecedented detail. Voyager 1 has ventured into a remote region of space never before explored, the interstellar medium, where the protective force of the solar wind no longer shields our solar system. Since crossing the heliopause in 2012, Voyager 1 has been measuring the plasma environment as it drifts farther from the Sun. This region, usually calm and quiet, emits a constant, faint hum of intergalactic gas detected by Voyager. According to Stella Koch-Ocker, a Cornell PhD student and lead investigator, this hum is monotone and narrow in frequency, like a quiet cosmic buzz. However, every few years, the solar wind surges outward in shock waves, temporarily disturbing this quiet. James Cordes, a senior Cornell astronomer, likens it to hearing a sudden thunderclap in a steady rainstorm. These shock waves once seemed the only way to estimate the density of space beyond the Sun's influence, but with the discovery of this interstellar hum, scientists can now study the medium between shocks, revealing more subtle activity than previously imagined. Yet even a spacecraft as legendary as Voyager 1 faces the inevitable effects of age. Last year, the probe experienced a malfunction in its attitude articulation and control system, AACS, which ensures its antenna stays pointed at Earth. Mysteriously, it began sending distorted telemetry data through a computer that had been inactive for years. This unexpected error raised concerns about whether it was time to retire one of NASA's oldest and most successful missions. Fortunately, engineers managed to correct the issue by instructing the system to revert to its previous working configuration. While NASA assures the glitch doesn't threaten the mission's longevity, some scientists are already looking to the future. Ralph McNutt of Johns Hopkins University notes that the Voyager's continued operation is both a technological miracle and a stroke of luck, and so problems are to be expected after such a long journey. He and others are already preparing a proposal for a next-generation interstellar probe, which, if aided by a gravity assist from Jupiter, could launch between 2036 and 2042 and push even further into deep space. This proposed interstellar probe would aim to surpass Voyager's distance record and be durable enough to last at least 50 years. However, the mission is still in its early planning stages. Even with NASA's support for an initial study, it won't be officially approved until it passes review by a decadal survey committee, a process that could take several years. One might wonder why physical probes are still needed when we have advanced observatories like the James Webb Space Telescope and the forthcoming Nancy Grace Roman Space Telescope. The answer lies in their differing purposes. JWST and Roman are astrophysics tools focused on distant galaxies and exoplanets, while missions like Voyager and the Parker Solar Probe study the Sun's influence in space. Together, they offer complementary perspectives essential for building a complete picture of our place in the universe. While Voyager 1 is still active, scientists are making preparations for the day it falls silent. The spacecraft may soon stop transmitting, but it will continue drifting through the galaxy. Attached to both Voyager probes are Carl Sagan's famous golden records, engraved with sounds, music, and images representing Earth and humanity, intended for any intelligent life they might encounter. According to Nick Oberg, a doctoral student at the Kaptein Astronomical Institute in the Netherlands, simulations predict the records could survive far into the future, even as the probes journey through space for eons. Though the fate of humanity remains uncertain, the future of these two small emissaries of Earth is mapped out with astonishing clarity. As they sail through the stars, the golden records may one day be the last surviving artifacts of human civilization. The result is a prediction that stretches far beyond not only the likely extinction of humanity, but even beyond the future collision between our Milky Way and the Andromeda Galaxy, and the eventual destruction of most stars. Initially, the researchers had far less ambitious goals. Their inspiration came from the second data release by the Gaia satellite, operated by the European Space Agency, which maps over 1 billion stars with astonishing precision. Their first objective was to use this newly revealed Gaia catalog to predict which stars the Voyager spacecraft might one day pass close to. To do this, the team began by retracing Voyager's past trajectory and projecting its future path. But it's important to note that the Voyagers won't truly leave our solar system for another 20,000 years. When they finally cross the Oort cloud, a vast halo of icy comets and debris that extends up to 100,000 astronomical units from the Sun. Only then will the gravitational pull of other stars begin to outweigh that of our Sun. Even then, it will take another 10,000 years for Voyager to pass near another star, specifically the red dwarf Ross 248. This stellar flyby, expected in roughly 30,000 years, will likely be Ross 248 zipping past the almost stationary Voyager, rather than the probe flying directly toward the star. Fast forward 500 million years, and both the Solar System and the Voyager spacecraft will have completed a full orbit around the Milky Way. Although we cannot know what Earth will be like by then, this time frame is akin to the lifespan of entire supercontinents like Pangaea. Voyager 1, in particular, will oscillate far above and below the galaxy's main disk, reaching regions where the star density is half of what we experience near Earth. These oscillations affect not only the probe's environment, but also the potential longevity of the famous golden records attached to each Voyager. Beneath their golden sheen lies an aluminum casing, and within that, etched copper disks designed to last for 1 billion years in space. But in order to estimate their survival, scientists must consider the conditions the probes will face, which means understanding where they will travel. Of particular interest is the amount of time each spacecraft will spend within the Milky Way's massive clouds of interstellar dust. These dust grains, traveling at speeds of kilometers per second, act as a constant cosmic rain, slowly eroding the spacecraft's outer surfaces. Even microscopic particles can vaporize tiny pits into the probe. Voyager 1, due to its vertical motion, spends more time in these dust-rich regions, exposing it to greater wear. Oberg and his colleagues modeled the damage the golden records might suffer by running thousands of simulations, also factoring in how gravitational interactions with dust clouds might redirect the spacecraft onto new, unpredictable orbits. Depending on trajectory, some clouds may fling the probes closer to or farther from the galactic center. Interestingly, the golden records are more likely to remain legible because their engraved sides face inward, protected by the spacecraft's body. Still, Voyager 2's record could be more at risk, as its more chaotic orbit introduces more uncertainty into its long-term path and environment. Despite all this, simulations suggest both records could survive, mostly intact, for over 5 billion years. Beyond that, however, predictions grow difficult, especially once the Milky Way collides with Andromeda. That massive galactic merger, while distant in the future, is expected to dramatically deform or even destroy the Milky Way's iconic spiral shape. This event will likely influence the Voyager probes as well. In fact, Oberg calculates there is a 1 in 5 chance that the merger could eject one of the Voyagers from the newly formed galaxy altogether, sending it drifting alone through intergalactic space. In such a scenario, the probes would face threats from cosmic rays and hot gas molecules, although less frequently than the constant battering of interstellar dust they endure within the Milky Way. The outcome depends largely on how much dust the collision creates. If dust levels drop due to a slowdown in star formation and explosions, the Voyagers could survive even longer, potentially for trillions of years, offering a long-shot chance for these small artifacts to outlive almost everything else and traverse a truly alien universe. Thanks for watching another episode on Voyager. While you're still here, be sure to click the next video on your screen for more mind-blowing stories about space.